As Comet K2 journeyed inward through the solar system, astronomers began noticing something extraordinary. Despite being over 2 billion kilometers from the Sun at the time of discovery, K2 was already active. That activity has only increased as it continues its inward path, forming an impressive coma and a dramatic tail that make it unlike any other comet in recent memory. So, what's causing this comet to behave in such a lively way, even from a distance where most comets would still be frozen and inert? Normally, comets become active, meaning they develop their coma and tail, only after getting significantly closer to the Sun. That's when the Sun's heat causes sublimation, turning the frozen gases inside the comet into gas and dust, which then escape into space and form the iconic features we associate with comets. But Comet K2 defies this expectation. Its coma, which is the cloud of gas and dust surrounding its icy core, is already huge, with estimates suggesting that the dust cloud is almost the size of planet Jupiter. That's a diameter of about 140,000 kilometers, all created just from the comet's internal ice reacting to the increasing heat of the Sun, from very far away. What's even more astonishing is the length of K2's tail. Astronomers believe the tail could stretch as far as 500,000 miles, roughly twice the distance from the Earth to the Moon. That makes it one of the longest cometary tails observed in recent decades. Even more intriguing is the fact that it seems to be in a permanent coma state, meaning the comet is continuously releasing gas and dust at an unusually steady rate, something that suggests there might be more than just solar heating at play. Some experts believe that volatile compounds, chemicals that sublimate at lower temperatures than water ice, could be fueling this activity. These may include carbon monoxide, carbon dioxide, or even ammonia ice, all of which can turn into gas even when a comet is far from the Sun. If these materials are mixed throughout K2's body, they could explain why it has stayed active for such a long time and at such great distances. There's also a chance that K2's nucleus, the solid part of the comet, may be more porous or fragmented than average. This would allow heat to penetrate more deeply into its structure, triggering more sublimation from inside out. However, we still don't know for certain. That's why Comet K2 continues to fascinate researchers. It doesn't behave like most comets we've studied before. As for the true size of K2's nucleus, there's still some debate. Initial estimates from ground-based observations suggested it could be as large as 100 miles wide, which would make it a true giant among comets. However, more accurate data from the Hubble Space Telescope places the size at a more conservative 11 to 12 miles, 18 to 20 kilometers across, still large enough to stack two Mount Everests on top of each other. Regardless of its exact size, one thing is clear. K2 is a rare and fascinating object, possibly unlike any comet we've studied before. It gives scientists a unique opportunity to explore what comets are made of, how they evolve, and how they can remain active even at vast distances from the Sun. At infinity beyond, we believe this makes Comet K2 more than just a bright object in the night sky. It's a mystery waiting to be unraveled, and a messenger from the distant reaches of our solar system. In our next segment, we'll explore what might happen to K2 next. Will it survive its encounter with the Sun, or disintegrate like so many comets before it? Stay tuned.